Hello, everyone, and thank you for joining our webinar today. We have three interesting presentations from experienced presenters. Todd Sutton will be sharing his experience in implementing different 3D printing application in construction projects. John Fish will talk about the utilization of 3D printed models during the design and planning stage. And we'll hear from Julian Kang how academia is teaching for 3D thinking. The presentations will be followed by a panel discussion session, and would love to hear from you. So make sure to post your questions in the question section, and we'll try to answer them all if possible. My name is Firas Hijazi. I'm the Information Systems Manager at Consolidated Contractors Company, and I'm the chair of Horizon 360, a subcommittee of Technology and Innovation Committee at CII. Now, first, let's start with the safety moment. 3D printing or additive manufacturing is becoming widely used technology. It's now less expensive and more accessible. It's used in multiple industry sectors as well as by end consumers. Still, it's considered relatively new technology, and there are no clear implementation guidelines or standards due to the different type of material used, whether it's plastic, rubber, metal, or different methods like high temperature, ultraviolet light, and laser. So some of the potential hazards that are related with 3D printing is that 3D printing can release particulates and harmful chemicals into the air. And users can get hazardous material such as metal powders, solvents, and other chemicals on their skin. Some material used can be flammable or combustible. High temperature from some printers can cause burns. So according to the National Institute of Occupational Safety and Health, NIOSH, it studied multiple ways to reduce exposures to 3D printing hazards. And some of the recommendations are to make sure that only trained users are accessing 3D printing equipment. Ventilation is very important precaution to minimize chemical emissions. And if possible, use material with lower emission. Also send instruction to printer about the final product you want to produce, and try to stay away as much as possible while the work is being done. And as part of your regular safety orientation, have a special training related to potential hazards, what precautions to take to stay protected, and how to behave in case of an accident. And finally, make sure that users are wearing the full proper PPE equipment. Now, a quick overview and history about CII. CII, or Construction Industry Institute, was founded in 1983 when 28 organizations started collaborating on study about cost effectiveness. It was clear at that time that an organization is needed to take a leadership role in construction research. Now, CII, based in the University of Texas at Austin, has more than 135 members who are forming a three-way partnership among owners, contractors, and academia. CII's mission is to provide the R&D platform to create and drive innovative solutions to improve business outcomes. And this is a list of the owners who are members of CII. These are a list of contractors, and these are the service providers. There are different communities and work groups within CII. Some of them, as you can see in the blue column, these are the sector-specific groups. The yellow one in the middle, you see at the bottom, the Technology and Innovation Committee. And this is the technology-related and research project related to the technology within CII. The green column is listing the specific topic community for business advancement. And these are all related to the priorities defined by CII members. So Technology and Innovation Committee, as I mentioned, it's responsible to define and follow up on the latest innovative technologies. There are three main subcommittees within the technology and innovation, in addition to the interoperability. The first one is Horizon 360. The second is the committee for innovation, and the third one is Path to the Future. Each of these subcommittees is responsible for different time frame of innovation. And the Horizon 360 committee is formed from a balanced number of academic and industry technologies who are meeting on a monthly basis, and they are seeking and identifying technology-based solutions and innovative practices that are implementable and cost-effective. Also, Horizon 360 members are forward-thinking and non-restrictive to the recommendation it provides. This means that we are thinking outside the box. We select the technology and we think which is the best way to serve the different community-specific groups within CII. We also serve as consultants, whether for different research projects evaluating these technology or for CII members who are doing real-life implementation of this technology. And at the same time, we are promoting technology to all CII members, whether through annual conference, exhibition booth, webinars, as we are doing today, or sharing knowledge through the wiki. Now, going back to our topic and our webinar. 3D printing is one of the top trending technologies nowadays in construction industry. Together with BIM, drone, IoT, AI, and other technologies. It proved to have many benefits such as cost reduction, faster delivery with less wastage. It's capable to produce complex shapes with better quality and safer process, using less resources. So a major enhancement was the tight integration with other technologies like BIM or 3D models for designing and building complex shapes, and with AI for learning from the past experiences to increase performance and minimizing errors by automating production. So today the technology is more advanced and capable of printing almost everything, yet it has its own challenges. And this is what we are going to discuss and explore during this webinar. Our speakers are leaders, each in his domain, with considerable experience in construction industry and academia. So they are going to share their practical experience of first hands-on field experience about using 3D printing. Our first presenter comes from construction industry with 32 years of experience. Todd is a senior project controls manager at Zachry Corporation, and he's going to share different type of printing models, products, and materials that he has evaluated and used, and he's going to share the challenges faced. John McQuaid is going to join Todd later on to talk about the workflow of starting 3D printing from DGN files. So the floor is yours, Todd.
Thank you, Faraz. Today, we're going to be covering some of the 3D printing processes and workflows that we've incorporated at Zachry Corporation. So, we've been doing 3D models for planning and execution for quite a long time. This is a model that we did in 1967 for the Hilton Palacio del Rio, which was a modular constructed hotel building that we built in 202 working days for the Hemisphere Texas World Exposition of 1968. This room that had 496 rooms for this particular hotel. And the model that you see here was actually done with balsa wood. And what we're planning on doing is recreating this model using 3D printing, but this is also going to allow us to do use that 3D model for planning future renovations for the hotel property. So here's our 3D printer that we have. It allows us to, or this is actually one of them, but on this particular 3D printer, you can see the printer in the back is an open source, open hardware 3D printer with a dual extruder system that allows us to be able to print multiple materials during one print without having to change out filaments in between. And to the right, you'll see the a pylon structure. That's the completed structure we'll be talking about in our workflow today. And then below, you'll see some smaller bridge structures that actually has an arches in it that's very complex geometry to 3D print. And with that, we used at the top, you can see the Polymaker polydissolved material that allows us to be able to print. We'll talk about that a little bit later. And then you see the tools that we use. And then we have a print dryer, which is technically a food dehydrator that's been converted to remove moisture from the filament to allow the filament to print more effectively. So today we're going to be talking about different types of 3D printing. The first one we're talking about is the fused filament fabrication. And this one works by heating up the filament through the extruder and then extruding it out and then applying it layer by layer. And this is used for like electrical housings, for different parts, spare parts. And you can even use it to create jigs and fixtures along with doing casting patterns. And some materials for this one also include the PLA, ABS, but some of the more new other ones are like nylon, glass fiber infused, carbon fiber infused, metal filled, and wood filled plastics. Here is an example of a tool that we made to allow us to use a servo pole on structural steel frames. This example is one of the bridges that we had with the polydissolve that we mentioned earlier that allows us to be able to print that complex structure. And then we're able to, as it prints each layer, it goes in and builds up the support structures, and then it'll print out it changes the materials for the PLA, the white plastic. So you see the translucent color in there as well. So and this trigger bridge was actually used by the team during our proposal because it's going to be a prefabricated bridge. So we was able to take this prefabricated or be able to 3D print it to show the owner how we was going to install the prefabricated bridge, basically doing an overnight bridge replacement proposal. So, and it was very useful for the project team. So. And as it Yeah, so as it completes, you can see we can actually take this, and once it's completed, we can put it into water, and then it'll dissolve, the poly dissolve, so we have a finished structure. It just leaves the PLA material. And here's an example of the pylon that you're going to be seeing during the workflow as well. So being printed out. And this is a 3D wrench. This 3D wrench actually is, I got it from NASA as example 3D print files, but they actually sent this to the International Space Station for them to use when they needed a wrench on board. The space station, so this is next we're going to talk about the resin top printers. This is a vat polarization. It actually uses a material that's a photopolymer resin, and the way it works is by lasers being directed towards the resin to solidify the material. So it does, and what it does is it will create each layer by layer, and as it completes one layer, the printer will raise up and then lower back down to print the next layer. So, and as it prints out, it'll go through. This type of printer is actually good for like jewelry, casting, dental applications, hearing aids, and so forth. So it can do a very smooth surface finish, but it's also very brittle, so it's not good for mechanical top parts. And here's some of the examples. The next one we're going to talk about is actually selective laser sintering. And this is part of the powder bed printers. And the way this one works is by also having a laser hit the material, but it's actually fusing the materials together. So it actually does layer by layer, and then you'll see the print bed will actually lower down after a layer is completed, and then you'll have a device go over and recover the powder material. In this case, it's a thermoplastic powder for the next layer. Once the part has been finished printing, then it's removed and then cleaned to extract the finished components. The next one we're going to talk about is the direct metal laser sintering. So the main difference on this one is using a metal powder, and it could be aluminum, stainless steel, titanium, for example. And it also uses a laser to do layer by layer. And then the print bed will lower down and then put more powder over it, and as it's building up each layer. This is an example of it's doing it from the side. And then once it's finished with this, there's another hardening process that you go through to make it to kind of a kiln to kind of harden the material, and then you clean it, and then you have the finished part. The last process we'll talk about today is called material jetting, polyjet. And this works kind of like a inkjet printer, and just with a resin material that's already in liquid form. And then what it does is it prints out the droplets for the different inks. So here's an example. Here's kind of showing the inks, and then you'll see the droplets, the resin coming from the nozzle. And what it does each layer by layer. And then there's that light that you see going with the print head, it actually is curing each level. So as it's doing each layer, it's curing it and doing layer by layer, and then the print bed lowers down each time as well. So. And here's an example applying the different colors. So I want to really briefly cover the different print services that are available. And I just want to point out two of the marketplace creators. So Dassault Systems, actually a CII member, they have a marketplace they created that consists of most of these services that you see on the screen, as well as some additional ones. But the nice thing about a marketplace, it allows you to upload your file to one location, and then you get quotes from multiple vendors on what on your project. And you can either choose to go with a single vendor or actually have multiple vendors be able to supply it for you. So I think it's a great thing that coming up with these marketplaces that help consolidate those different vendors in one location. Crowdcraft from All 3DP also is a marketplace with similar services available. So now I want to turn it over to John McQuaid. To talk about our workflow process at Zachry.
Hello, everybody. I was going to run through the workflow of what we have to 3D print our models here. We are provided DWGs, and in order for us to make a 3D printable file, we're using the Autodesk Inventor software, and we need a 3D file structure to be able to work with. And in this case, I'm using AutoCAD Mechanical to export a step file, and then we're going to import that into Inventor. Once you promptly open, just make sure that all the geometry points and regions are all selected. Once that loads, we're going to go through and we're going to copy, or we're going to make a copy named and stored in, my gosh. We're going to make a individual part for each one of the pieces that is imported, and then we're going to assemble them together. Here's an example of that, of the base part for. And then once we have all of our parts saved and stored in our directory, we assemble them. And here's an example of the completely assembled and modeled model. And in this case, we wanted to make the pylons connect to each other so that we can have a 4D model to work with our to help with the planning process for scheduling and all that. And so in this case, Inventor, one of the awesome features that it has is you can model within these assembly files using all the other parts. And these little sketches that you see here are actually referencing the geometry from the other parts. And that allowed me to very easily make these connection points that you see right here, and be able to, of course, use this as the 4D model that we needed it to be. And once we've completed that process, we found that it was much easier to make batch files for these components instead of individually bringing them into the 3D printing software. And the reason for that was that in that software, it's not as friendly for grouping together and laying out, orientating everything. And it also had it wouldn't import the parts to the correct scale too. So I mean, it just added a whole bunch of extra steps. So it's better to make these batch files in here, and then using the 3D printing tools that it had, just export those batch files out like this. Once we have our STL files, we import them into the 3D printing software, in this case, Cura. And as you can see, like I was stating, it doesn't import the the proper scaling. So we had to go in and manually rescale everything again, and orientate it all. And you'll get to see kind of how the orientation process is and the scaling, and it just wasn't very friendly in here. So that's why you want to use it in the do that process in the Autodesk Inventor platform. And to the right of the model, this little panel over here is where we have all of our properties for the actual print itself, like the materials that we're using, the speed that it's going to print these out, the infill, all of those settings are over here. And once you have all of that selected, and you need to export a G code for that, you'll see at the bottom here, or the bottom right, you'll see the save to file. And when you click that, if you have your SD card in there, it will automatically default to it. And then you just save your G code in there. It's going to add an extra, or it added a little bit of a prefix, I guess you would say. And we didn't need that, so I just went ahead and deleted it here. I want to keep the original name of the project. And so once that's done and on your SD card, the next step is to import it into the actual 3D printer itself and run the print. And here's the result of that.
Thank you, John.
Thank you.
So feel free to contact me if you have any questions.
Okay. Thank you, Todd, and thank you, John. Todd, just quick question that was posted. How much time did it take you to print the bridge?
This bridge right here, it was 14 hours. So that it took. Mainly the base itself was 100% infill, and then that was one of the items that actually took the longest. So yeah, that was. But that's a good question. This other bridge here, it was about I want to say about 9 hours, maybe a little bit less. So, but you can see there's a lot of detail in here. That's the other thing too about the sizing was to be able to get these steel members on to print out. We had to scale it up large enough to be able to print those out, because the smaller version of it, it just would not print those steel members. So.
Okay, great. Thank you, Todd, and thank you, John.
Thank you.
Okay. So now we move on to the second presenter. John Fish is the Director of Innovation and Technology at Ford, Bacon, and Davis. And John is going to talk about the utilization of 3D models in the different stages of design and planning, and he will give us examples about how we use the conceptual model to support funding for construction projects. So, John, you have control. Yeah. John, can you hear us? We cannot hear you.
Sorry about that. I forgot to turn my mute off.
Okay.
Okay,
No
I've
problem.
titled this Back to the Future because, as you can see on my bio, I've been around for a long time, over 50 years. I started in technology and piping design back in the 1960s and 70s, and we actually created plastic models by hand. We built them by hand. Next slide. So the computer technology, when they came out with 3D, they said, well, we didn't need any more plastic models now. We can get away from that because we have this 3D technology and it makes it easier to see. Next slide. It's kind of true, but not really true. There are a lot of people that are outside of the engineering industry, specifically talking about operators, even business people, owners, maintenance individuals, that they really have difficulty looking at a 3D model. When you look at a 3D model on a flat screen, it's still 2D. It's not really 3D to them, and it's very difficult for them to conceptualize the sizing and the spacing. Next slide. So we looked at the value of a 3D model. I don't care whether it's printed or built by hand, but it's used for a lot of different things: support funding, assist operations to ensure operability, look at ergonomics and safety, and what I call the abilities. The abilities are installability, constructability, operability, maintainability, all of these abilities that you can look at you can do it in a 3D model, but it's even better if you have a plastic model. And the really cool thing about a plastic model is you can take it to the job site. Now we have and here's one of the first applications, by the way. We print out a lot of the equipment early in a project. We'll print out the equipment. It's movable. It's not connected to anything. So you can start actually doing a plant layout. And the beauty of this is the operators and maintenance people can start moving stuff around, seeing what it would look like in different configurations. Once you've got one that looks like it's pretty good, next slide, we can actually go in and start putting the construction work areas. So it's assisting you in your construction work area or AWP planning and application processes. Next slide. Here's another example. This is a material handling project. You can actually build these things with movable walls so that you can make the rooms larger. The equipment is not tied to anything. So again, it can be moved around, reconfigured to the satisfaction of the owners, operators, and the maintenance people. And again, you can assign your CWA, your AWP planning. So it's going to assist you in that. Next slide. Now, the main thing is you can take a model to the field and go to the next slide. So the key here is, whoops, we're getting a little bit of echo back here. The key here is that owners and operators and maintenance people come into your engineering. Go back next slide. That's fine. They go to the they go to the engineering office. They got maybe an hour or two, maybe a half a day to look at that model. Let them take the model back to, with all the pieces, let them take it back to the control room. Let them spend a week with this thing, playing with different configurations. This is really, really valuable to get their feedback, and it gives them a much better feel for your project early in conceptual design, and it's going to prevent a lot of changes. Okay? Next slide. Again, conceptual model, funding. A lot of business people, a lot of people who are going to approve the project, they can't read drawings. They surely don't know how to operate a 3D model unless somebody, a trained pilot, is there to help them and everything. But here you go. Now they can look at this plastic model and say, this is what we're buying. This is what we're going to get. I have several examples of this. Next slide. So again, here's a wastewater treatment plant. Beautiful model, and they can see exactly what they're going to get, all landscaped and everything. Makes it easier to ask a lot of questions and ensure that we all see exactly the same thing and what we're getting for our investment. Next slide. Again, conceptual model. Here's one. This is an operating building, but we took the sides away, took the roof. So this is what it's going to look like inside the building. But it makes it easy for everybody, specifically, again, operators and maintenance people, to see how they're going to run this plant, how they're going to operate it, what it's going to look like on the inside. Next slide. So here's another example. In this case, we have three skids that we're going to bring in. How do they fit? How do they fit in with the existing tankage? And how are we going to be able to maintain and move around this thing? How are we going to be able to install these modules? Next slide. How it works. We have some complex equipment, so we can actually take the skin off the equipment and show you inside what's happening to these cyclones and regenerative processes here. Over here, we can see we got an oil derrick. So next slide. So again, we keep talking about accessibility, operability, maintainability. That's really the key to getting your designs approved. If you can't operate, if you can't maintain it, you got some real problems. Next slide. So several examples here. There's a bunch of tankage. Notice we didn't try and model all the piping. The main thing here is looking at the equipment, how it's going to be, how we can move around that equipment, how we can get that equipment in, how we can get that equipment out for construction planning. So you don't have to model everything. You only model what's required. Another view of looking at accessibility, operability, relatively compact unit here. How are we going to get in? How are we going to maintain this thing? Next one. Again, operability, maintainability, constructability, just a nice little model, makes it easy to understand. Now look at the arrows. That first arrow on the top, do we need a pipe support here? How about the second arrow on the left on the bottom? Do we need a pipe support there? Look at that little crossover style. Is this a tripping hazard? Do we need to put more protection for operations here? These are the kind of things that become really apparent when you build a plastic model. It makes it easier to spot situations. And by the way, we did need a support up there at the top, and we did need to do something to prevent that tripping hazard on the bottom. Okay, go ahead. Next one. This is just to show you the detail that a 3D printer can do. This is the grading. It's got actually angle handrails on it, little hand wheels on the valve. You put a little man on there. So you can get fairly detailed. As Todd stated, you do have to upsize your piping components sometime. If you got a 1 inch or an 1.5 inch, less than 2 inch piping, it's going to be upsized a little bit in order to make it so that it's printable. All right, next slide. This is an interesting story here. We actually did a 3D model review, and we had the operations and maintenance guys in, and they have to pull this compressor out of this building every 3 years for maintenance. So we had a big discussion on how are we going to do that. And we came up with some ideas. Now, during the lunch break, and these people, we didn't even make an announcement, we brought in a pre-printed 3D model of that same structure with removable parts and pieces, as you'll notice, which you can do with a 3D printer. It's pretty easy. And go to the next one. So what we did, we started taking the sides off, and we moved some components out of there, some of the steel components out of there, and immediately these guys started walking around the model and talking. Next slide. And they came up with a way that says, you know, if we remove this and we remove that, then we can actually save $30,000 on our maintenance costs every 3 years for this particular compressor. So that little model, which costs $3,000, is going to save them $30,000 every 3 years on a turnaround, just by making it available and making it easy for them to see what all the different options were. Next slide. Again, this is kind of another view with everything removed, so you can see what they have to deal with here. Next slide. Now we have constructability planning. Notice we actually have little cranes you can put in here, and we can actually 3D print this crane. We can 3D print almost any crane you need and then put it in the model itself so you can check out lifting capability, swing on the crane. They're actually movable, workable parts. So it's pretty cool. Next slide. This is the bridge that Todd was talking about. Todd had another one. I should have got a picture of that, but it helps you do some complex structures. Next slide. These are some more examples of bridges and buildings that are complex, relatively difficult to comprehend with a drawing. Even on a 3D model, they may not be clear, but when you can look at them in plastic and walk around, it makes a big difference. And the cool thing here is if you got a building, we can actually print the floors so they're removable. You can take them off and look around that building regardless of the number of stories that you have. All right, next slide. So again, we're going to just summarize here. Basically, it just makes it easier for everybody to see. Not everybody operator, non-engineering people, they really don't click to a 3D model real well. And in many cases, your 3D model operators aren't very good either. I get airsick with some of these guys. They start flying around a 3D model so fast, and it's difficult to see the whole thing. You get a big shot and you zoom in and then you spin around and then you get upside down sometimes. So it gets a little bit complicated. So we really need to give these guys something they can work with. And the real value is if they can take it to the field during construction, if they can take it to the field during the pre-operation planning so that the guys can start looking at their operator training and maintenance planning, et cetera, prior to the completion of construction. It's really, really valuable and well worth the investment. Matter of fact, I have heard that in Asia, in some of those countries over there, they will actually hand build a plastic model, even though we have a 3D model, just to have solve some communication problems between the different people that are working on the project, the different cultures and all. Okay, next slide. So when do you do this? FEL2, early and front end planning, movable parts, helps you get your concepts down, your spacing down, and define your path of construction for AWP. FEL3 is your conceptual model. Now you're defining your construction work packages, you're finalizing your operability, maintainability, and constructability issues. Detailed design, you can actually print out a very small scale model of this thing. Doesn't cost a lot, and you can print it out on a monthly basis, and they'll show you in colors what's in place and what's not in place. Again, as we talked about construction, let them take this thing to the field. Let them help plan that. Every morning you'll find those guys doing their plans, working around that model, what they're going to do today, what they're going to do next week. And of course, operations wants that to train their people prior to the startup. Next slide. So barriers and challenges. Okay. Model builders, there's only a few that have the ability to do those piping systems. Powder printer is usually the best, but some of the others are available. We have to, like I said, you have to scale up some of the piping sometimes because the small bore doesn't print real well. Cost, the materials are not cheap. That compressor building that you looked at was roughly a $3,000 model, and it took 2 days to print that particular model. Relatively complex because we had some removable pieces, but still, I think it was well worth the time. And you have to compare the cost of printing a model to what it would take to hand build a model. You don't have to build everything. You don't have to print everything, but print out the things that are most complex, the things that are going to be of most value to the people who have to operate this thing, have to maintain this thing, and have to build this thing. Next slide. And that concludes my presentation. Contact information for me is on the slide, and we use IMS as our model printer on almost all of our projects, and I've got the contact information for that. Thank you all very much, and I'm turning it back over to you, Frias.
Thank you, John. Excellent presentation. We have a quick question for you. The question is, which process did you use to produce this model?
That was a powder printer.
Okay, great. Thank you, John.
Mm-hmm.
So now moving from industry to academia, Dr. Kang is an associate professor of construction science and at Texas A&M University. And he's going to examine different construction projects with complex shapes, and he's going to explain to us how higher education is teaching for 3D thinking. So Julian, the floor is yours.
Okay, can you guys hear me?
Yeah, can hear you well.
Okay, very good. So Todd and John gave you some ideas for the opportunities and challenges we may face when using 3D printing. Now I want to take a look at the issues related to 3D printing a bit more broadly from the educator's point of view. What we want to achieve with 3D printing is basically to build something that is not possible to build using traditional method. So to some extent, we can say that the building you're looking at is now something you cannot build easily without using 3D design and the 3D production method. What you're looking at is a Dongdaemun Design Plaza, DDP, built in Seoul, South Korea. It was designed by Zaha Hadid and built by Samsung Construction. I guess the first thing that catches your attention, hold on one second, let me move on. It's not, can you go back? Okay, here we go. I guess the first thing that catches your attention is the curved panel. And unlike the one-way curved panel used in the past, this building is covered with the panels that are curved in all directions. And then next, please. I guess oh, here we go. This image shows a building from a higher elevation. As you see, the whole building is quite different from the surrounding box-shaped buildings. And next. And obviously, no one can design this kind of buildings efficiently without using any 3D computer modeling tools. And as far as I know, they use the CATIA. I guess a 3D computer modeling tool like CATIA enabled them to think more freely and more creatively when designing a 3D space. Next. And DDP opened in 2014. It took 4.5 years for them to build. And this is the photo that I took when I had a chance to visit Seoul in 2014. Next. And this is the night view of the building. I guess some of you may think that you're looking at some kind of a spaceship. Next. Now back to the panel issues. DDP is covered by 45,000 omnidirectional curved panels, and none of them are alike. I heard that Samsung Construction had a quite bit of trouble installing these panels. So how did they do that? Next. As far as I know, they used a multi-point press machine, which is getting the geometry of each panel from the CATIA model. And thanks to this press machine, they were able to produce 45,000 panels in just 20 months. Without this press machine, I guess it would take much longer time for them to produce the panels. So we can say that this is an interesting example of the challenges we may face in building a creative buildings that is designed based on three-dimensional thinking. Next, please. This is another example of a 3D fabrication. What you're looking at is the Morpheus Hotel in Macau. And this building was also designed by Zaha Hadid. As you can see, what makes this building pretty unique is that the entire building is covered with an exoskeleton that mimics the internal structure of the natural creatures. The exoskeleton is also used to secure the structural stability of the entire building. Next. And the exoskeleton can be seen from inside the building as well. As you can see, it makes the interior space very unique. Now you may wonder how they built it. Next, please. And as you may guess, they fabricated modules using and then assembled them to the job site. In the job site, I guess we all can agree that no one can design this building without 3D thinking. And again, the 3D fabrication made this possible. Next, please. And then 3D thinking and digital creation are also being tested in academia as well. And this is the styrofoam arch that we digitally fabricated at Autodesk Build a Space in Boston. A group of faculty and graduate students from Architecture and Construction Science Department created a 3D model of the modules to be used for the building an arch. Next. You can play the video. Here we go. Okay, so we sent this video to a 6-axis robotic arm, and it cuts the styrofoam module automatically. And move on, please. And click one more time. It has a video as well. Okay, so we thought the arch could be built quickly by simply connecting the modules together. However, as you are about to see, just wait a second, here we go. The arch was collapsed during the assembly process. So what happened was the interlocking part of the module was broken. Go back, please. Due to a stress concentration. Next, please. And this experience prompted us to explore structural stability issues of the modules, and soon we learned that the aircraft manufacturers were trying to secure the structural stability of their plane by mimicking the internal structure of the human bones. And this was very interesting to us. So we decided to try something similar. Next. Okay, so what you're looking at is a process where simple beams are being advanced to be more structurally optimized in handling internal stresses. The one in the middle shows a typical example of a cross-section optimization to reduce the weight while maintaining its ability to resist the stresses. What we were wondering about was whether the interior of the beam could be filled with some tissues to achieve secondary member optimization. This attempt was only possible because of the additive printing. Next. So we wanted to see if this could be achieved by inserting some sphere space inside the module. So Dr. Niraj Yadav, who earned his doctorate degree in spring, created a 3D model using Autodesk Fusion 360. Next. And this is what he printed. And as you can see, this is a kind of a pretty rough. From this test, we learned some limitations of additive printing. Next. So to avoid some disadvantages of additive printing and to produce modules more effectively, Niraj created a 3D computer model using Voronoi tessellation. Next. And by combining these modules, you can fabricate the arch. Next. And this is what we fabricated. One thing I want to emphasize here is that we didn't produce any two-dimensional drawings when fabricating these modules. Even if we produced the 2D drawings of the modules, I guess it would not help us much. This suggests that it may become increasingly difficult or even impossible to describe future structures using two-dimensional drawings. So, if our students are not prepared for 3D thinking and digital fabrication, they may not meet the demand from the construction industry in the future. Then one of you may ask if the educational curriculum in higher institutes help students overcome these challenges. Next. And unfortunately, in many cases, we still teach our students in a way we learned. For example, we teach students how to understand the design intention by reading two-dimensional drawings produced using orthographic projection. Next. Next. Okay. So I teach students how to read the construction plans from building a building in a cyberspace like Revit. And I hope this method helps students gain some ability to connect two-dimensional drawings and 3D objects. Next. But this educational curriculum was originally created on the basis of the traditional communication method, where architects explained the 3D structure using two-dimensional drawings, and the builder reads two-dimensional drawings and gets some idea of the 3D structure desired by the architect. Next. And advances in 3D printing may give us the opportunity to eliminate the use of the two-dimensional drawings here. A 3D model alone may better explain a structure that is difficult to explain with conventional method. And ironically, the classes I've been teaching may be what keeps students from embracing these new ways of communication. Next. So as far as the 3D design and 3D in 3D space, we already have some commercial applications that allow us to create objects without considering two-dimensional representation at all. Next. And Gravity Sketch you see here is one of them. With this system, you can create the car you want in a virtual space in a whole different way. Next. And this photo suggests that the design collaboration will soon be possible as well in the virtual space. Next. So now, how about construction? This photo shows a construction manager observing through HoloLens an object to be constructed, projected on top of the members that were already built. So can she build the building without using two-dimensional drawings at all? How about determining the dimensions of the members? The ability to observe the 3D model through HoloLens may not support the construction of traditional buildings as much as we may expect. Would it be possible to remove two-dimensional drawings at all from construction? Next. A concrete bridge that Zaha Hadid architects and ETH built together for the Venice Biennale may give us some answers. They produced the concrete modules using 3D printing for this project as well. Next. And they use a 6-axis robot so that each concrete layer printed has even some slope. Next. And these concrete modules were transported to Venice and assembled. In this whole process, they use no two-dimensional drawings at all. And I think this example provides us with some direction for what kind of a curriculum should be developed in the future. Next, please. In the case of module-based construction, perhaps you may recall the method that Zachry Construction used in 1968 when they built the Hilton Palacio, Del Rio in San Antonio. I bet Todd has a ton of story to share with you about this project. They prefabricated the entire hotel room and delivered them to the site. And thanks to this method, they placed 496 rooms using a crane in just 46 days. And it took only 220 work days from design to construction and occupation. Next. And these prefabricated modules are coming back again thanks to BIM. And blocks you see is one of the examples. They are oriented towards industrialized construction. At the heart of this strategy, they have 3D models and modules. I believe this method is what we need to pay attention to in developing a new curriculum. Next. So obviously, we all see that 3D printing and 3D design have a huge potential to change what we do, but will it also help us build a building without using any two-dimensional drawings at all? Will it eliminate the use of 3D printers? John and I have been talking about it, so what do you think? I guess that's all I have.
Thank you, Julian. Excellent presentation, as usual. Heather, can you run the video, please, before we start the panel discussion?
Okay, so this is a Consolidated Contractors Company. They're 3D printing a house in this particular video. And this was unique because they had to come up with a mixture for the concrete to where it would apply each layer smoothly, but also provide a good finished product. Here you can see they're using a robotic arm. And here's an overview of the finished product. Here's from Zachry Construction Corporation. We have this is using a GOMAC GP4, which is the slip form paver. And we uploaded the 3D concrete paving file to this and put concrete in front, and we're able to basically extrude the paving from the 3D file operating it. This is from Georgia Tech, one of the students, Mickey Kim. This is basically a 3D drone that they printed out, and they've been able to map out the spaces in the area. This is an example from Hyperion Robotics. This is 3D concrete printed wall. So this is showing doing complex structures with 3D printing. Here's an example of a curved wall. And the last one was the column. Thank you.
Thank you, Todd. So I will ask all the presenters to join me to the panel discussion. And I welcome also Alejandro Aguirre, is the head of innovation and knowledge management at Techint, and he's going to share with us the experience they gained when they tried the 3D printing in one of their projects. So let me start first with one of the questions by the attendees. Very good for 3D printing the prototype for planning purposes. And I think he's referring to what John Fish used in his presentation. And then he's continuing, I can see a lot of value from this. I would like to ask if you are able to 3D print real parts that will be installed into the projects. So Fish, if you want to start answering.
I'm not sure I understood that last part. Want to print what parts?
The attendee is asking, I would like to ask if we are able to 3D print real parts that will be installed into the projects.
No, this is the presentation I get is a plastic model only for visualization. It's not real parts.
But you can design and print real parts and supports and stuff too. So, and that's where those 3D manufacturers that we talked about, or the different outsourcing companies can also come in, because they can 3D print in metals, different types of, even titanium, for example.
Yes.
Hey, Todd, this is John Palmer. I have a question related to that. do you see that there's coordination with testing and certification for products that are going to be used in the field? So if it's, I don't know, ANSI or ASME or someone like that.
Yeah, I mean, that's one of the hurdles when you're developing, they're trying to implement any new kind of process, means and methods, and materials even, because specifications don't allow for it sometimes, and getting that approved either through the specifications organizations or specifically the building permitting, your local jurisdictions, whether you can get it approved or not, or on top of that, the owner specifications as well. So, and that's something that we've struggled a lot with DOT work as well, getting those when we're trying to implement some kind of new material or even a new process. So.
And coming back to printing the real part using 3D printer, I think I heard that Airbus in Europe were printing the real part using obviously metal or some aluminum to use for the real airplane assembly or renovation. But I'm not sure if I see any cases going on in the construction industry yet.
Yeah, I have where they actually printed like structure, like components that were interconnected to traditional constructed materials as a joining piece, kind of like a cap. So I've seen it done on several jobs. So.
And we have follow-up to this question. He's asking, do you expect to have a major impact on projects drivers such as quality, cost, or schedule using 3D printed models?
Yes, I think it could, but I mean the other thing too, we've even used it for like our equipment department to print out replacement parts, mainly covers and stuff, that get broke off. So
I have a little bit, I guess, different view on it. I guess it all depends on what kind of a building we want to build using 3D printing. If it was totally a traditional box shape building, then honestly, I don't see many chances to see, the 3D printing is going to change the way we do. But if it was about building some crazy, shape or facade, stuff like that, and I guess 3D printing has a huge opportunities to innovate what we do, for construction.
Alejandro, do you have anything to say? You're muted.
I don't hear you.
I want to point out anybody really interested in 3D printing. There's a lot on YouTube, and there's a company called Relativity Space. They're actually printing space rockets now, and another company is actually printing jeans. They have a weaving machine that prints custom jeans. So there's just all kinds of things you can do with this 3D printing.
Okay, can you hear me now, guys,
Yes,
from the panel?
Yeah.
So I wanted to say something related to our experience as EPC contractors. We are making a pilot on printing with reinforced concrete with Hyperion, and we are analyzing to 3D print real components of our industrial facilities. We are starting with the trenches of the drainage system of our real projects, and we are planning to move forward towards foundations and supports and manholes. So things that can be printed with concrete, reinforced concrete, with fiber concrete. So we are looking into that plan for the following future, near future, I mean. So this is a very exciting time. And I think that is thanks to companies like these startups, which are very smart people, combining robotics with materials technology and digital process design.
Okay, thank you, Alejandro. I have a question for Todd. Todd, in your opinion and experience, what's the biggest challenge in 3D printing technology? Is it material, complexity of shapes, or cost, or anything else?
Yeah, I think it's is what John pointed out. John Palmer asked earlier about the specifications. I think that's the biggest hurdle as far as getting the approvals to put it on the job. And you know, unless you're the owner that's and also that's kind of coming up with that process, it's really hard to get it to do the adaptation. I think the technology is here, and it's proven because there's several different manufacturers that have implemented it. That's all they do is 3D printing parts, and so that it is a viable business. And like we pointed out, the 3D concrete paving. I mean, we're transforming a traditional equipment into using the 3D model file to be able to extrude out that paving using traditional materials. So we kind of came up with a workaround to use the traditional means and method and updating it with 3D model files.
I think also that a challenge is going to be like approaching or making these technologies, making them closer to the owners, who are the owners of our projects, the projects that we build. So we want to introduce these new technologies, and the owners, they should be like closer to this and start analyzing the standards that can validate this technology. And also new standards are being written regarding, for instance, 3D concrete printing. So this is very important for the industry to move on and keep up with technology, because new standards need to be written and for the acceptance of this technology.
Right, and that's one of the things where a couple of years ago, the office building in Dubai, where they 3D printed the office struct building, and they actually had to go and get it approved for the permitting agencies. So that's one of the things they first started talking about, even while the buildings were being built in China, before it was transported over, to get it approved, to allow it to be installed, once it got there. So I think, again, the specification is really the driver.
I guess we have a lot of questions for John Fish. John, one of the questions, is there a view of the benefits of building 3D plastic model relative to using either the virtual 3D for a plant walkthrough or a hologram projection?
I think that technology is coming pretty fast. I think hologram has some merit to it, but quite frankly, most of the VR that I've seen is a singular experience, and it's still difficult for a group of people to gather around something and talk about it. The hologram, that's another story, but that technology is a little ways down the line yet, I think. And you're looking at it for a plant, and that's, I don't know. I just haven't seen it in action yet.
Yeah, I agree. I agree with that.
Okay, another question, also to Fish. For the plant 3D printed models, is there a typical scale relative to the actual plant that you are actually constructing?
I think we were using 1/2 inch to a foot, roughly, that particular scale. So you got to look at your unit a little bit and how much you really want to show. If you're going to show the entire plant, you're going to have to scale it down a little bit. If you want to show specific unit, like where I showed that grading and all, I think that was, I can't remember the scale, but it was at least 1/2 inch to the foot, or possibly 3/4 inch to the foot, to show that kind of detail.
And I think also it depends on the level of details you want to include in this printed model. Yeah.
Right.
I'd like to add one comment on John Fish's plastic model. When I was in the industry long time ago, working on nuclear power plant design and construction, we also produced a plastic miniature model 1:10 scale. And for that plastic modeling, we allocated about $1 million just for plastic models, believe it or not. And then I totally agree with the benefits that people are getting from being able to touch the miniature model to discuss, what they want to do, stuff like that. I never thought about coming back to plastic miniature model, through a 3D printing. But after hearing what John, you were saying about, plastic model being printed, I think it's totally making another good sense. So I guess some companies might be testing, printing out those plastic miniature model using some plastic, 3D printer. And then I think, as far as I see it, is making perfect sense.
Okay, Julian, I have a question for you. If there were any difficulties in teaching construction in higher education, I mean, what would you like to bring up?
Okay, the biggest challenge from the educator's point of view in terms of helping our students being able to think in 3D or come up with some ideas to how they want to build a building without using any two-dimensional drawings is, ironically, I have not been educated to go with the 3D thinking. So, I had to come up with some idea how to teach students to be able to think in 3D without having my personal experience. I guess that's the most biggest challenge I have ever experienced. So I guess I'm looking for some opportunities to be able to, get myself exposed to this sort of a 3D thinking or 3D fabrication, stuff like that myself, so that I can actually experience the limitations and challenges, that we're going to be facing in using new tools to design the 3D space or to fabricate something in 3D. So myself is most biggest challenge that I will have to get over to teach students how to think in 3D, ironically.
Bish, do you have anything to add? Or let me ask you the question in a different way. How do you see the 2D drawings are preventing the construction industry from migrating to the future?
Oh, I'll answer that one. I've had the vision of think of a world with no piping isometrics. I don't think we need piping isometrics at all. I don't think we need steel fabrication drawings at all, plans and sections. I think in the steel and the piping discipline specifically, they can go away. We can use our 3D model, our intelligent 3D model, and we can pull the views we need. And take the example of piping. The fabricator needs the data from the pipeline. They don't need an isometric. They can pull the data and actually have automated pipe fabrication. The steel fabricator can do the same thing. They can pull the steel information, metadata from the intelligent model and fabricate the steel. So that leaves you with the 2D drawings themselves. And as Julian pointed out, the 2D drawings, if you show the 3D little model right beside it, it helps you to understand that. We're getting to a place where people can't even read 2D drawings anymore. It's very difficult for them. So why not just pull the information from model? Model views like IKEA uses for assembly views, that's what we really want. And I've got hundreds of examples of assembly views. Our field planners are doing that today. They're taking our 2D deliverables, our 3D model, and they're actually making annotated assembly views for the craft. And easy to understand. It's just, I don't see why we need to be issuing ISOs. It's a throwback from the 1950s.
Firas, can I make a comment there?
Yeah, of course. Yeah. Go ahead.
Okay, so our company is also trying to go the way that John is commenting, and we're trying to implement digital spots for consultation on site for supervisors to see the 3D model in the key points of the facilities that we're constructing. But it's hard to remove the paper from the site up to now, but we're in the process of trying to remove paper and install like digital consultation points. And that is, I think, like a hard path to follow, but we are on that track.
I would like to comment on that one, too. The foreman I talked to, you can remove paper. The craftsman, the actual pipe fitter, he says, look, I have to climb up a 30-foot scaffold. I've got stuff hanging off my belt. I've got safety issues. I can't take a laptop or an iPhone or anything up there with me. I have to have a piece of paper. So what we're actually doing is we're taking those little annotated 3D model views. We print them on a piece of paper, usually 8.5 by 11, 11 by 17. That guy can fold it up, stick it in his pocket, and get up there in the bright sunlight. When he said, I can't even see my screen digitally in the bright sunlight, but I can see that piece of paper. So you can't get rid of paper, but you can get rid of the ISO. Is how do we present the information so that they can more easily assemble their work? That's the challenge.
Okay, great. I think we have like a few minutes, so we're going to take I think the last two questions, and I'm going to ask Todd and Alejandro, in what type of implementation did you achieve the best ROI? Is it like the concrete, the pavement, or spare parts? Whether I'm talking from cost, benefits, ROI, or quality.
Right.
Todd, you go first, Todd.
Yeah. So from the on the concrete paving, I guess the fact was that we have a shortage of skilled labor, right, in the industry as a whole, and so instead of having a separate operator for the 3D paver, we actually have the surveyor that creates the 3D model, that concrete paving model that is uploaded to the equipment. He's also the operator of the equipment, so that it limited. So that was the biggest return on investment is, having a multi-skilled individual that can operate it. But also because we were merging traditional with the new process, we benefited from the output of the traditional method that was applying the 3D model file. So I think that was the biggest part of it. As far as the spare parts, that's a no-brainer, because when we needed something, we could just print it. And you're talking about, like on a lot of those parts, like the wrench was like, 30 cents to print out. So as far as cost of materials and stuff, so it's very effective to use that process.
Just before moving to Alejandro, since you mentioned the spare parts, how was the quality of the spare part? Is it durable as the normal one?
Well, it depends on the process that's used. So if we're using the different plastics, we found that if we used, like on the printer that I have, I can use carbon infused filament, which gives me additional strength to the material, so then it is durable. And then when it comes to like if it's something that's required that's working in a heated environment, then obviously we go ahead and send that outsource that to get a metal printed part for that.
And I guess the most important advantage is having it just in time whenever you need it.
Yes.
Rather than
yeah, exactly.
Okay, so Alejandro.
Yes, so I can tell you a little bit of our business case that we analyzed with the 3D printed concrete elements for our project in Mexico. And we saw huge savings everywhere, from productivity, the speed of printing, to sustainability issues, not producing waste, like lowering the emissions of carbon, embodied carbon, and also having less people to take care of in pandemic situation, and also having the ability to prefabricate in a sheltered condition. In our projects in Mexico and the south states of Mexico, it's very rainy, so having the possibility to prefabricate those sections in our warehouses is like valueless. I mean, it's very valuable. No? So there are lots of benefits, and also regarding the reduction of events in the traditional task of handling the formwork and bending, cutting, reinforcements. That's also a very, very singular point that needs to be included in the business cases. Even that you cannot fully make it like countable, the benefits, the economical benefits, but there are other benefits like sustainability and safety and quality that should also be considered. But we had lots of benefits, and that is why we are moving into this technology. And we had the possibility of considering that like in situ or on-site 3D printing workshop and mobilize 3D printing equipment to our projects. And I think that's a game changer for us.
Okay, just because I think it's an important question to ask, although we're running out of time. One of the questions is, what is the view of the panelists on the topic of design for manufacture and assembly in relation to 3D printing? And the second part is, can you relate the topic of 3D printing to sustainability?
I guess I have some comment on DFMA. It's basically about heading into industrialized construction, which is basically about producing a part, the vans, and then bring the parts to the job site and then get them assembled. So we have some people seeing no differences between assembling Chevy trucks and building the buildings. It's basically the same thing. You bring the parts and get them assembled on the job site. I guess the 3D printing and the 3D thinking, 3D design, everything is heading towards to this direction. And that's one of the reasons why I'm kind of dreaming of like eliminating two-dimensional drawings from the construction industry. If we are able to just fabricate building like we are assembling IKEA furniture, then we might be able to remove, those two-dimensional drawings totally, and then 3D printing and then 3D, computer application, modeling application is definitely helping us to move on to that direction.
Okay, great discussion, great question, and thank you all. Thank you for the presenters. Thank you, Alejandro, for joining, and thank you, John. I didn't have the chance to introduce John Palmer. John is the Associate Director of Technology, and these are the contact information for John and the other key personnel in CII. And you can follow CII on the social media. So thank you everyone for joining, and look forward for other future webinars from CII and from the Technology and Innovation Committee. Thank you.
Thank you.
Thank you.
Okay, bye-bye.
Bye.
Thank you for having me.
Thanks, everyone.